Hello, everyone. Welcome to the Automation Firehose, Be Strategic and Tactical. I'll be your host for this session. My name is Thomas Haver. I work for M&T Bank as a master software engineer. My primary focus is on test automation and DevOps practices. I post regularly to my team's blog at Red Green Refactor. Before I was in IT, I was a scientist for around a decade studying molecular fluorescence spectroscopy and microscopy. I'm also an avid board gamer, owning over 3,000 board games, take up an entire room in my home. And I'm an evangelist for Ruby Cucumber. That is my primary tool set. I like to help teams adopt behavior-driven development. Of course, I've got a lovely family here, also in cartoon format. Let's dive in. Right. To talk about the strategy and tactics necessary for test automation, we have to first begin with an origin story to set the level. When I talk about strategy and when I talk about tactics, what I mean is a strategy is a plan of action or a policy designed to achieve a major or overall aim, whereas tactics is the art or skill of employing available means to accomplish an end. So, for instance, Star-Lord here had a great strategy for defeating Thanos, but his own emotional tactics ended up costing his team. Microsoft had an issue way back when in testing Internet Explorer. Their issue was that they had way too many primary testing variables when they wanted to go through any sort of new release or update with Internet Explorer. Going across multiple service packs, different language binaries, it became impossible for them to actually test everything, even though that they had tremendous resources available. Their solution at the time was to sort of bucket together the most commonly leveraged combinations of operating system with browser type and look at specific sort of customer profiles that they could generate, the persona-based testing. This challenge that I present here is similar to one that we faced in test automation and one that we've faced for decades, is that it's impossible for us to test everything, so where do you find the most value? The promise for automation has always been that it's going to save time and lower costs while raising quality. But we know in practice that's rarely the case. We end up having to invest time to make automation successful for the long term. So in order for us to be successful, we need to make sure that automation is not some discrete activity, as you see here in a diagram, where you introduce automation after the cost and time to deliver rises and your test coverage and quality declines. And then magically you get increased quality and test coverage and reduced time and cost to deliver. That's not the case. When you implement test automation, you're doing it for the long haul. So it is something that has to be continuous for the lifespan of the application under test. So how do you approach this? How do you make sure that you can be successful? Well, one thing that I like to do is ensure that at least all team members are making the same judgment call when they're going into their tasking or specification workshops. They need to ask the question of what should we actually automate? And following a sort of set of questions of, is it something that's repeatable and how often? How much time could be saved? Are the requirements of the test low risk, stable, and unlikely to change often? Is it subject to human error? Is it time consuming? Does it contain significant downtime between tests? And is it repetitive? These are common questions that you want to ask whenever you're going to do net new work to make a determination of what you should or should not automate. Additionally, you need to change your mindset when it comes to what you should actually automate, because test automation scripts should be treated the same as development code. That is to say that every new test script should factor in maintenance costs. Additionally, some basic maintenance costs include automation tools, operating system upgrades, language upgrades, as well as the documentation and the onboarding that you have. You're not just simply snapping your fingers and having automation take place and be successful. You're investing for the long term. You're developing it the same way that you would develop any other application. Additionally, you have organizational constraints that are limiting your ability to be successful with test automation. You're always going to be limited by the delivery schedule, your project budget, and your technical skill set of the people involved. You should automate based upon the frequency of use or criticality, including your legal risk. Additionally, you should look for complex manual scenarios that require a great deal of environment or data setup to assist you. One of the ways in which I like to help people engage in this activity is to create a so-called automation scorecard. In this case, I use simple check marks, but you can use, say, on a scale of 0 to 10 if you like for each area. And what you need to do is examine and look at what are the most valued areas that we care about for test automation? As in, is it on the critical path? Is it highly frequently executed? Do you have some legal compliance for it? Does it require a great deal of data and environmental setup? Is there likely to be opportunities for reuse of these scripts once you write them? And then for each feature in your application, you want to identify either on a scale of 0 through 10 or a simple check mark here of whether or not something will be valuable. Then you can go through and stack rank them, highest to lowest priority, to make that determination of what are the most valuable features you should focus your attention on first and work down the line. Anything that did not meet the criteria is one that you can skip, as in you should not automate that. Or if you've run out of time, you can at least identify areas of technical debt where you need to automate, but you did not manage to do so in the time box. When going through and selecting automation tooling and determining your frameworks, it's not a one-size-fits-all, especially for an enterprise. It could be something that works well for a team, but is suboptimal for the larger enterprise. So what you want to do is make that sort of determination of the right tool for the job. So let me go through an example here. Here's a very simple and poorly written Gherkin test about validating Azure DevOps services. This is a web test written with Selenium, which is an open source tool. Underneath, the primary language used is Ruby, and Cucumber over top for that plain level domain language. So this is something that can be useful for people who are working with largely UI-driven applications, where you want to implement behavior-driven development from the perspective of the end user. You care a great deal about the end customer. Selenium, from this example, as a tool that you would leverage, is one of the most popular in the space, especially as an open source tool. And if you're going to make the determination of whether or not we should adopt it, say, for web-based applications, you have to make the consideration of, can you align the net new tooling that you want to do with your existing tech stack? You want to try to keep your tech stack as streamlined as possible. One way to do so is to adopt tools that fit in with the existing tech stack, something that biases towards developers actually adopting it and leveraging it for testing purposes. Selenium is great because it's been implemented in just about every single language under the sun. So it makes for a very easy choice for adoption. Additionally, when you're talking about framework, you want to maximize the amount of time spent on testing, minimize the amount of time that you spend on maintenance. It goes without saying. But here's a simple for instance of, if I want to make things highly reusable for this web-based test, and I'm clicking on a lot of things in a web application, I want to reuse that same bit of code, in this case, these 5 lines for clicking on anything on the page, again and again, rather than re-implement it every single time I have a net new test. And the example that I'm giving here is really written in an imperative style, which is UI driven, which is not really great for BDD. But what you end up doing from a framework perspective is wrapping those small imperative style tests into declaratives that describe the user's behavior and not their specific UI-based interaction with the system. So you can refactor out the UI and be more clear in the purpose for your tests. Additionally, we should focus on all layers of our application and faster feedback. So UI tests can sometimes be flaky. Therefore, using integration tests or testing the UI are much more powerful because we can ensure those components work as expected. We can use pretty much any sort of tool that would fit our existing tech stack and implement and get faster feedback. And taking this to its logical conclusion of faster feedback, we of course want to implement unit testing. It's the fastest method of testing. It's easier to debug. It's highly reusable. It's the lowest cost to fix. And whatever language you're using, you have a tool that can fit that job. So what are some of the common challenges that I've seen people encounter in adopting test automation? One of those is the automation firehose. This is where you're given a fresh new tool, you like it, so you try to apply it everywhere. But just because you can automate something does not mean that you should. You want to adopt a risk-based approach for your automation, using an automation scorecard and a checklist to help you along the way. Additionally, people have problems with data, insofar as they have data that can work in a single environment and the test executes successfully in that environment. And as soon as you migrate to a new environment, the test fails. You want to make sure your test data access, as in all of the CRUD access, create, read, update, delete, is available in all environments that you're testing it. So that way you can write the automated test once and execute across multiple environments to be successful. Additionally, I've seen people have issues with flickering tests. These are tests that you execute and they pass, execute again and they fail, execute again, pass, fail, flickering, green, red, off and on. Automated tests that don't consistently pass are soon ignored by the entire team. The execution report and notification email should mean something to the people receiving them. You either fix or remove those flickering tests, and you want to examine why you wrote the flickering test to begin with. Additionally, I've seen exceedingly long tests that are 300 steps long that validate dozens of things. Unit tests and integration tests should take the priority over those UI tests. They run more quickly and are more robust, and you want to automate the UI as needed. And ideally, each test validates one thing, no more, no less. So that means no 300-step scripts, because once you have a failure at a certain point, it skips the rest of the validations and goes on to your next test. Also, I've seen people build with a shaky foundation, as in they automate to get to the done state for that story, to get to the next day. And they end up accruing a great deal of technical debt in their framework to the point where you end up throwing away the framework eventually and starting over from scratch. You want to treat your automation code the same way you want good development code to be treated. You want to implement good practices such as don't repeat yourself, keep it simple, stupid, with scheduled code reviews, code analysis tools, and refactoring sessions. You want it to be the first-class citizen alongside your development code. Lastly, I've seen automation lag behind development by a sprint or two. How can you actually say stories are done if you haven't fully tested it? You want automation feasibility baked into your definition of ready and completed scripts in your definition of done. You need to have automation execute successfully, at least in an environment, before you can say, hey, the story is ready to move over to the next environment. You do so by implementing those practices that I mentioned, so that way you can have automation working concurrently with development work. So in summary, what did we learn here today? Well, it's important to focus on the fastest, most robust tests. We want to create UI and end-to-end tests as needed. So focus on unit over service, service over UI, and UI over those very long end-to-end. They can go across multiple applications. You want to build your automation based upon the probability of failure, the impact on business, as well as complexity. And lastly, budget, schedule, and the technical skill set of the people within your org are always going to limit the path forward. Don't work under the ideal circumstance. Optimize for the circumstance that you are in. I want to say thank you very much for attending my session today. If you have any questions, you can feel free to reach out to me. There's my email, my Twitter, my LinkedIn. More than happy to help you out. Additionally, if you're looking for a change in your tech career, and I would strongly consider you looking at M&T Tech. I've got a QR code there. We are a mid-sized bank, $100 billion, based out of Wilmington, Delaware, and Buffalo, New York. We're recruiting a great deal of tech talent across the board. So if you're interested, feel free to reach out to me. Thank you very much for your time, and take care.